Hi, I'm Sean Goggins. I'm also new in the School of Information Science and Learning Technology. The work that I'm going to talk about at a high level is the work that I've been doing the last 4 years at Drexel University. So I was an assistant professor at Drexel for 4 years. So I'm giving you an overview of a general sort of part of my research agenda. And if you want to sort of think about what it is I do, you could think about how do you think in your own life, how does a company or some kind of firm's analysis of your behavior online influence your life? Can people suggest ways that analysis of the ways you behave online influence your life? Heather?
I was very irritated yesterday when I logged onto the Daniel Boone Regional Library website because I wanted to renew my books, and it made me agree to terms of use for their online catalog. And I wouldn't do it. In order to renew my books, I had to agree to the terms of use of the online catalog.
Okay.
Two separate things. So I wouldn't do it because I don't want them poking around at what I'm doing.
So that's an issue of policy, right?
It is a policy
The question
issue,
is you don't want your
I
behavior
don't want
traced.
the fact of the matter is I'm reacting to their policy by not sharing that data with them.
Okay, good.
I recall a study that said, and it was very broad brushstrokes, the people who use yahoo.com email addresses are generally overweight, middle-aged women of a certain background. The people who use Google addresses generally are using them back. They're thin and beautiful and dressed in black. And I had both.
I have a Gmail address.
Gmail and Yahoo. The Gmail address I don't use for special things that I'm really excited about. The Yahoo address I use for junk mail. But because I use it for junk mail, more people identify me with the Yahoo address. I'm like, oh gosh, I'm old and middle-aged, and oh no.
Good. Sandra, are you raising your hand?
7 years ago, I bought a book for a friend of mine that was supposed to be a joke about parachuting. And up to this day, I still get references on Amazon about recommendations for books to buy related to parachuting. And I would like to turn this off because I have zero, -100 interests actually in parachuting. So they keep going.
Zach?
I use Spotify, but I share my account with my daughter, who's going to be 5 soon.
Oh gosh.
Oh.
So,
I know this story. Go ahead.
well, I don't know if it's one particular story, but it also shares what I listen to on Facebook. And so when Taylor Swift or Katy Perry come up, and I get a lot of flack for that because I have very specific music tastes that are basically the opposite.
Yeah.
And it also then fills my Spotify when they make suggestions. Neutral Milk Hotel and Katy Perry, completely different things.
I share a Netflix account with my daughter, so I feel your pain. The number of Middle Eastern documentaries that I get recommended are ridiculous. And Zach and I have to confess are Facebook friends, and I've been one of the people who taunted him over the Katy Perry thing that you were playing. So the point of that exercise is to point out that there are lots of ways, and I think most of the ways that we think about how the traces of our behavior are analyzed are fairly simple commercial kinds of applications or terms of service kinds of decisions about whether or not we want to share. And a lot of the work that I do looks to try to identify deeper ways that we can make sense of our behavior online and use that analysis of how we interact with different kinds of systems to make our interaction more visible and to increase our understanding of how people interact online. So the contexts that I research are constructs. So in research we talk about constructs. I look at coordination, leadership, and knowledge construction. Most of my work the last 3 years have been focused on these constructs. So these are the things that I try to operationalize in my research. And I've looked at software development, disaster response, online learning, industry contexts when I explore how these constructs can be operationalized, at least partly through the trace data. So there's a sexy new term for some of my research in the learning context, which is learning analytics. So if you've heard the term learning analytics, and when I think of sexy, I think of a goat. I don't know why. That's just, see, I don't even know what kind of animal it is. It's, I'm not an agricultural person. That's that furry thing there anyway. So, oh. Moving right along.
You can't separate the sheep from
It doesn't get better, right? If you're familiar with the television program South Park, there's a famous episode where there are these characters called the Underpants Gnomes, and they have a business model, and the business model is collect underpants, profit. And the sort of what's being parodied in this episode is the whole dot-com bubble, which is, companies would form, they would do something, whatever it was, and they would have no idea what to do next, but their vision was profit at the end of it. And much the same thing happens in a lot of studies that analyze electronic trace data, where people will collect the traces or logs from a system, try to ask some questions, and then publish what they call results. And so there's a lot of found data that's being published as research today, and the thing that I'm trying to do is shed light on how to specifically make sense of that found data in a way that is grounded in how people are actually experiencing the systems that they're in. So the fact that we interact on Spotify or Facebook or in an online learning system doesn't directly, so my access of an artifact doesn't directly translate into necessarily interest in that artifact or the fact that I've read that artifact. And so what I discern from time spent or effort exerted in a discussion forum or editing a wiki needs to be accounted for specifically. And so instead of making a bunch of assumptions about what these traces of behavior mean, I try to get a bit more specific about what's happening. And so as researchers, we're trained to come up with a research question and design the collection of data to answer that research question. In the online world, a lot of times we're starting with data. And so one of the steps we have to do is we have to figure out how the data was generated and then find a research question that that data can answer. So it's quite inverted from the way that we're trained as researchers to think about research. But when we're looking at online systems, a lot of times this happens. This is not something we can necessarily even avoid if we're researching an online environment, because even if we go into the environment with research questions, it's highly likely that the logs of behavior, if we want to use that data, have been determined long before we've asked our research questions. And so what questions we can answer are constrained by what is available from a system. And this is, to some extent, called data-intensive science. And as an aside, before I sort of go over this slide with you, in an NSF proposal 3 or 4 years ago, I identified this gap in the analysis of trace data. And the gap is that a lot of people looking at Twitter or Facebook or online learning are using highly computational clustering algorithm sorts of methods to group people together. And they arrive at a set of clusters or associations, and then they say, this is what we found. And this is what they found is often not really directly related to the thing that we're interested in studying. So it may not directly map to coordination or learning or knowledge construction, but it's what can be found in the trace data. And as a young researcher, I referred to this phenomena of not asking the research questions in a theoretically grounded way as computational mysticism. And the social scientists on the panel really loved the proposal, and the computer scientists on the panel did not. So there's this challenge that we face when we're trying to do this kind of research, and that computer scientists view the kind of work that I do in one particular way, and social scientists view it in another particular way. And this sort of comes to bear from a computer science perspective when we rely on very large data sets. So from Twitter or Facebook, these would be considered large data sets. They often involve this data mining behavior, which as researchers that like to ask theoretically grounded research questions, we would regard that as phishing. That would be it's a pejorative term. It's not a compliment to say that you're phishing in data. And back 5 years ago, Wired magazine said, well, it's the end of theory, that all of this data-intensive science means that we don't actually need theory anymore. I think since then that assertion has been shown to not be quite the case. But at the time, and all the excitement around what was being called big data, they said, we don't even need theory. We can just find whatever we need from data. And so having a lot of data and having a lot of processing power is really changing the way we think about things, because we have these very powerful computers. And how we compute things and how we store things is very different now than it was even 5 years ago. And at its core, the data that a lot of the data that I look at, and one of the things about the work that I do is it's not just the electronic trace data, there's always some other kind of triangulating data involved, is that it's activity traces. You can call these log files. So a lot of times, it's even when I today review articles or have articles of mine reviewed, I use the term electronic trace data, and at least one reviewer every time doesn't know what that is. And so I've taken to just referring to it as what it is, which is log files. That's sort of the colloquial way of thinking about what it is. And it's, as I mentioned earlier, found, not produced for research, event-based. So it's not a summary. A lot of the statistics or data that we look at are summary statistics. Behavioral data, this is all, every single thing, every single click, a lot of times is recorded. And so there's a lot of data. And it's longitudinal. There's always a time dimension in the data that I'm looking at. It's never, I have to decide what time snapshots or what time groupings I want to put together, and that decision about how to group time together is a pretty significant decision. I can show very different results if I organize time differently using the same raw electronic trace data. And so we have to assign meanings to these events. Every event has to be assigned some kind of meaning, right? And so some events enact or summarize a relationship, like a marriage ceremony generally summarizes a relationship in most cultures. There's some kind of strengthened bond that's occurred. But most events in trace data are evidence for the raw material of the relationship at best. So what does it mean when I friend you on Facebook? Does that mean that I know you? In my case, it does. But many people friend people on Facebook who have never met each other. So there's this, what it means when we're friends, what it means when I comment on your post is not clear, and it's not the same from person to person, even though the behavior is the same. And so what that means is we need to characterize the profiles of a person's behavior in other cases in order to understand what their behavior in a specific case means. And so all this is getting to what are the validity issues in the analysis of electronic trace data. There's a lot of them. So if you think about, I've got two screens here. It's like, I don't know which way to go, so I'll go with this. You have an information system, some kind of event data, nodes and links, and that becomes a network that you can measure and construct. And so there are these issues of system and practice, reliability, what kind of links do we operationalize, how do we determine how intense the relationship is, how do we account for links that are missing from a particular system. Usually, I don't know, raise your hand if you only interact with one electronic system. Yeah, none of us do, right? We all are interacting socially and at work with, in my case, probably a half a dozen every single day, and I imagine I'm pretty typical. And so there's missing links if you're looking at any one system, this decision about how to aggregate things in time, the effects of the tools that we use. So sometimes network tools have the measures that we use for network analysis. When I do that, are buried deep inside of some tool, and we need to understand as researchers what those algorithms and measures actually mean. So that's an example of how there are all these validity issues with the analysis of electronic trace data. And the interdependent high-level issues are theoretical cohesion. So if I'm interested in coordination, am I making sense of the trace data in a way that reflects coordination behavior and not sort of, for example, diffusion of information? So information can propagate through an electronic system. When one person shares it, another person shares that share. And at the same time, there can be work taking place where we're trying to coordinate an activity. So I see this on GitHub, for example, where you have both information sharing and coordination work, and making sure that you're interpreting the right data, the data that's related to coordination, if you're interested in coordination, and not taking up the data that's related to information propagating through the system. It's an important decision process. Then conceptualization, or what are the constructs? So I started the talk out by being very specific about the constructs that I focus on in my research. And I do that because it's really easy to lose sight of what the constructs are when you're looking at these seas of data. I mentioned temporal aggregation, completeness, and then the context of use. So what are people really using the system for? And do you have a good understanding of how people are interpreting their behavior in the system for their own sake? In other words, we're not making a lot of assumptions that overlay our experience in a particular system on top of every other user of that system. One of the ways that I sort of try to make sense of electronic trace data across systems, and I think one of the things that's unique about my work is that I've looked at over 20 different electronic systems and online community types of systems. And so I've looked at a lot of different kinds of log data. I've designed a lot of different kinds of data collection. And so from this diversity of experience, I've come up with what I call an ontology and a process for approaching the analysis of electronic trace data. And the first component of the way that I think about how to name things when you're naming electronic trace data is to think in terms of interaction. So each record of behavior that a person has that's recorded by a system is really a record of that person interacting with something or some other person in the system. It's not a record necessarily of an interaction with the system. It's a record of an interaction between something. And the two dominant things, and I haven't identified much else in most systems outside of Twitter. Twitter is the anomaly for everything I'm talking about right now. It's a very different kind of thing. I've started to refer to Twitter as participatory mass media because it's really very different than every other kind of online community system when it comes to the trace data. So the two kinds are artifacts. I'm interacting with a thing, like a piece of paper or a software artifact, or people. The classic example being a discussion board. Usually my behavior is related to interacting with some other person. And so naming the things that we're doing, or the things that we're looking at, helps to give us a context for the work that we're doing in a particular electronic system. And that context is, the decision about whether or not the traces are reflecting interactions between people and other people, or between people and artifacts. And then the other kinds of external events, tasks and resources and technologies that are in a system. And at the end, what I end up doing is an aggregation of what I call a contextualized interaction, which is this idea of, here is the interaction between me and an artifact or a person in a system, and here's all the other data about that interaction. For example, maybe what class it was in, or what software project it was on. What is the time distance between that interaction and the next interaction? So in some systems, like online discussion forums, the time distance between interaction really matters for assessing the strength of relationship between two people. In other contexts, like software development, the time distance between my interaction between a software artifact and another person's has no bearing on the strength of connection between us whatsoever. It's really kind of the organization of work, and it can be completely independent. And so at the end of that, I come up with a very specific way of operationalizing any trace data system and what the logs might mean. And then to get to what the logs actually mean, and I'll use the example of a discussion forum. In a lot of the work that I've done with software engineering and with online learning, I have both records of read data, which is really cool to get. It really helps you to describe the strength of relationships between people and the diffusion of ideas, because if you've taken an online class, you're familiar with what happens. You have people who post a great deal, and they look really active. And in Blackboard, you have really no visibility into who's reading a lot of things. And when you do have that visibility into who's reading a lot, you get a very different perspective on who the key people in your course are. And so I have often that kind of data. And what I'll do is I'll classify it. So when I look at a Facebook group, I'll classify it by the topic that people are talking about. When I look at online learning, I might classify it by whether they're working in a small group or working with the entire class. And basically, using a technique from grounded theory, I come up with a list of codes by looking at all of the posts and then a code book that I go back over and code everything with. And then identify, so if I'm looking at coordination, I'll identify coordination events and focus on those. and then I'll aggregate posts by the topics that I came up with in the classification scheme, and then I can look at, for example, a discussion forum. In this example, I think comes from a disaster response scenario where I had read and post data, where I was able to look at, we had coordination around medical, logistics for power, and GIS information requests are two of the topics. So I was able to look at who the networks of people were around those particular topics and identify key people in those topics. And so that's an example where by knowing who read the data, I was able to tell who the key coordinators are. And they're not the people who post the most. And so that was the insight from that particular paper. Oops. There. And let's see. This is an example from software development where people are coordinating around tasks. If I want to identify opportunities to collaborate, so one of the things that happens in software development is you have two people editing a piece of code who are completely unaware of each other's behavior. And so by looking at which pieces of code a person has open on their desktop at a point in time, we can tell developer A has these sets open, developer B has these files open, and these are the two overlapping files. And so with that, a student of mine at Drexel and I are working on identifying developer to task intersections so that we can recommend to developers what other people they might want to coordinate with. So it's like a hidden coordination requirement. People are working on the same files, or looking at the same files, but are not aware of each other's behavior. So it's making those hidden coordination needs more visible. And this would be an example of slides gone wrong. So we also can I can also identify groups by manipulating collaboration opportunities of people working with software artifacts, what are called bi-clicks, and subsets of the developers. So I can basically do what's called the dichotomization of the opportunities, and then compute the sets of developers who gravitate towards common types of work artifacts, and look at which developers are often seen together across work events. And then this is an example where we had both bug tracking. So in software development, how many people are familiar with the software development environment? Am I just talking over your heads on that? So I mean, basically, if you think of it this way, the way that it works in a commercial setting and an open source setting, you have a list of things that are people submitting bugs to the software. So when you call a software company and say, hey, this isn't working, that becomes a bug on some software development list, and some manager will prioritize that bug against other bugs. And then you have another set of artifacts, or that I call work, which is when developers are actually touching code. And so there's a network of people who are talking about fixing code in the bug tracker, and there's a separate network of people who are actually touching code and fixing it in the software repository. And so when I talk about a software engineering problem, it's this dichotomization of work and talk. I have work behavior and I have talk behavior. And the networks overlap to some extent, and where the networks overlap gives me interesting insight into when coordination's taking place and explicitly and when it's not. And to compare those kinds of networks with each other leads to additional insight over if I just look at one. Does that make sense? Okay. And I'll skip past this because it's just another sociogram. In the talk network, so one of the things I did is identified work groups in the talk network, and you can see if you go up, the different colors basically mean more cohesive groups. So group 5, the orange ones in the middle, it's the most cohesive group, and then the least cohesive group are the red people out in the periphery. Much like Star Trek, the red shirts are almost disposable. And worked the Star Trek one in there. And so this is basically how I can represent visually these cohesive blocks of people working together or not working together that I alluded to earlier. So team awareness, the bottom line is that the empirical work demonstrates the accuracy of this method that the group I've been working with at Drexel has developed. And that the experiment was, everything I'm talking about was retrospective, which means that I didn't look at this data in a live setting, I looked at it in a after the fact kind of setting, but what we learned after the fact can be used and is being used to develop tools to enable things in real time. And basically, the end result is actionable support to members and managers in software and other kinds of organizations. So what's next? One of my projects is really focused on these kinds of virtual organizations, and so the use of trace data to understand how work and talk and organizations develop, and looking at the structural flexibility of an organization. So if you can imagine, how many people are familiar with open source software? Okay, so if you look at an open source software project, there are people who come and go, and there are people who stay, and lots of people come and go, and this is only becoming, it's exponentially greater in terms of the number of people who participate on an open source repository called GitHub, which I've been studying for the past 18 months or so. And so the flexibility of these organizations is really interesting. And the weakly held belief is that organizations that have these kinds of fluid participation models have some advantages when it comes to performance. That allowing people to come and contribute this whatever high-level skills they have in a particular focused way and then leave enables an organization or a project to function at a higher level than if they have a fixed workforce. And so does this, first of all, first question is, does this advantage really exist? And if it exists, how do we measure it? And so the work I've done has been looking at how do these organizations think about their own success? So that gets to how do you measure success in a revenue neutral organization like education would be a similar kind of revenue neutral organization. And can we prove or disprove the belief that flexible organizations perform at a higher level? So that's a big thrust of the work that I've on one of the grants that I've been working on. That's my NSF VOS grant. And some of the ideas from this work is starting to get applied to online learning environments, online learning contexts, which has fueled a couple of new NSF proposals that I have currently under review. And I think given time, I will just say that thank you. Questions? I threw a lot of things out there, so.
I don't have a question, but I do have, oh my gosh, you're going to be so useful to work with. I see so many possibilities where you can advise me.
Good. Jenny?
So, I do more only qualitative work, and this seems to be, it's looking about the data that's already been reproduced and you're pulling from it. Do you feel like there would be any value in adding qualitative research to some of these questions?
Yeah, definitely.
Find out why people are behaving how they are? Or do you find out why they're behaving how they are by looking at the data?
So it's funny, I didn't emphasize it in this talk. I have a JASIS paper that talks about how when I look at electronic trace data, I'm very, very explicit about using qualitative research methods and using the qualitative work that I do in a particular socio-technical context to inform how I interpret trace data. And I didn't.
Talk about it. I'll hear.
Yeah, so that's when I presented the ontology, that diagram of the core being interaction. That ontology, how I decide what an interaction is and what the time weight means, is really based on qualitative work. It's not usually based on analysis of the trace data itself. It's talking to people who use the system. So how I name and identify how to make sense of trace data for a particular system comes from qualitative work. And then there's a model that gets fed into the analysis of the trace data for that particular system. So yes, there's qualitative research is a big part of the work that I do.
No, if you have a real question, go ahead.
I come from the channel. I'm very interested in the report. I have the project from the channel, the Ministry of Education. It's called analytics. I'm from the research. I only think the LLS involved.
So I think you asked me about learning technologies and big data and
Yeah.
what I think the future of it is, in a sense, right?
Yeah. I'm sorry, I'm
So I'm trying to make sure I got the gist of it. So I think big data is it's an idiom for describing a lot of things that are in the world now. And that the really interesting, for me, the things that are most interesting are more related to what I would characterize as medium data. So with big data, I can do things like what we talked about at the beginning. I can make Amazon recommendations. I can make Spotify recommendations. And that's actually a well understood, simple algorithm of looking at what's called a vector in computer science and looking at the similarity between two people and between 1,000 people and making recommendations. And that's a lot of what we see with big data. I think when you start to try to understand how knowledge is constructed or how information diffuses through online learning systems or collaboration systems used for work, that the data is smaller and that purely computational methods are insufficient for producing useful insights. And so you have to do qualitative work to try to make sense of what is in the trace data and then produce something that's useful for people from that. And it's a harder problem than big data, actually. And therefore, to me, it's more interesting.
So
Yes, future.
we have constructed the LLS system.
Well, I construct a system?
Yeah, your LLS learning analytics system. So we will write the paper about the construct the LLS system. This the paper is showed about the architecture of the LLS, fundamental of the LLS.
Okay, I mean, you could share, if you have paper, I think?
Yeah, we will share. We will think it's very important to the LLS.
Yeah, we can talk maybe a little bit more offline. Twyla?
I liked your quote that read at the beginning of your paper about or your presentation about that we reached the end of theory. We
Yeah.
no longer have a need for theory. And I think the big data people are now saying we've reached the end of statistics. We no longer have
yes,
a need
I've
for
seen those
samples.
headlines.
We can take, just survey the whole thing. So, so obviously you were struck by this theory one. Can you
By the death of theory comment?
by the death of theory
Yeah.
comment. So can you just elaborate? Because I think it's so it seems to me that these are the sorts of comments like at the turn of the 20th century when people, all kinds of famous Harvard and Princeton professors were saying, we have now discovered and invented everything that's possible to discover.
Right. So I think that people did computational work with trace data, and they came up with some really quick and interesting insights about, look, men who shop before a snowstorm buy peanut butter and beer when they buy diapers, and it was like revolutionary that we had these insights just from data.
Mm-hmm.
And then we were interested in much more complicated kinds of human behaviors, like, well, how do I know if these 10 people in an online class are going to learn? Which of them is going to learn the most? Is there any way I can predict that? Well, all of a sudden, just looking at the trace data, you get clusters of people and you try to look a little deeper, and the person who's most active, who's at the center of the network, isn't really doing anything at all except saying hi, great, to every single post that every other person makes, right? And so just the data itself it started being actually misleading in a way. And so in order to figure out, well, how do I tune the way the computer is going to make sense of this, we had to go back to theory. We had to go back to theories of human behavior and test those theories and see, we used to think that people couldn't dominate an online class, and that was one of the advantages of online learning, was that the dominant person in a room, the vocal class member couldn't take over. But they can, if you just look at the traces of behavior without a theory of how things are happening there. And so theory becomes really important. if I'm interested in coordination, I'm going to interpret trace data really differently than if I'm interested in knowledge consumption. And so what I want to know is important. It's central.
Yeah,
in
so
fact.
you're just good, I guess I'm just thinking of how does this pertain to you? And of course, the more complex the information that we can gather, then that takes theory to a whole other level of organization rather than we will sort of discover everything.
Right. And when you talk, just on your end of statistics comment, I do think there's an interesting, there is a contribution that computer scientists have made to statistics, which is that there's a different model of statistics than the one that we're traditionally trained in, which is Bayesian statistics. And I think that the fundamental idea is that you have a prior probability, then you look at what happens, and you have a posterior probability. So you can constantly be evaluating the likelihood of certain outcomes. And its probability is at the center of the discussion instead of the p-value. And in some of the work that I do, that is more valid than trying to come up with a sample and a p-value or a ANOVA. And so I don't think it's the death of traditional statistics, but I do think it's an interesting set of new methods that is relevant for the kinds of data that we can gather today.
Thanks.
Sure. I guess this is over at 1 o'clock and I'm holding these.
I think officially it's over at 1:15, but there's,
Okay.
Thank you.
Thank you all. Thank you.